Hello, everyone. Let's have a look at this exercise on the confidence interval on the difference between two means. So far, we talked about three cases. Now let's have a look at the last case, paired observation. So the journal Human Factors, 1962, page from 375 to 380, reports a study in which N equals to 14 human subjects were asked to parallel park two cars, okay, having very different wheelbases and turning radius. So the time in seconds for each subject were recorded and is given in the table below. So you see the same subject, okay, same subject park two different cars. So this is the first type of car, this is second type of car. And this is the same subject park two different cars. So these are the paired observation for two different cars for the same subject. So this is called paired observation, okay? Because the same subject drive two different cars, and then we are trying to see the parking efficiency of two different type of cars. But the person we are going to do the test, they are the same human subject. They are in a total of 14 human subjects. They drive two different cars and then park them respectively, okay? And then we can get the difference when this human subject park these two different cars. These two different cars has different, they have different wheelbases and a turning radius. So this is D1, this is D2, and this is D3 difference. And until we go to D14. So the question is, please find 90% confidence interval on the difference in the time taken to parallel park two automobiles. So mu1 minus mu2. So this is case 4, paired observations. Why? Because the same human subject parked two different cars. And if you look at the case, so paired observation, and we are not given the population variance, so we still have a t distribution here. And this will be the confidence interval. So we mu1 minus mu2, that is the difference between two cars in the parking efficiency. And then we use d bar SD instead of separate two samples. The main reason is these are the paired observations, so we focus on this difference. Okay, that is numbers. This is a number, this is number, okay, the difference. Now, two sample problem become, now we focus on the one sample that is a difference now, okay? So the equation will become mu d will equals to mu1 minus mu2. So mu d is the difference in the time taken to parallel park two different cars. So this will be less than d bar plus t alpha over 2, and this will be n minus 1 sd square root of n. Let's move this a little bit. Now greater than d bar minus t alpha over 2 n minus 1 sd square root of n. So how many differences we got? We got a 14, right? We got a total of 14 difference. So n equals to 14, and then we have n minus 1 equals to 13. And alpha over 2, because this is, we want to find out 90%. Alpha over 2 will be 5, so 0.05. So alpha is 0.1, then alpha over 2. Then T alpha over 2 is 0.05. and then 13. Okay, so D bar. Let's find out the D bar. We have this. This is we can find based on the difference. We can find the D bar and the SD. Okay. So where did we get this 19.2? This is this minus this equals to 19.2. 25.8 minus 20.8 equals to 5.6. Okay, so we make the difference. We take the difference between this, and then we got the difference. Yeah. So now let's check T.05, 13. Let's go to the T table. T.05, 13. 13 is right here, 1.771, right? So the 0.05, 90% and 13. So let's go back. This equals to 1.771. Now what we want to get is D bar and SD. You can use the Excel and you can use calculator, and now we just save the calculation. D bar is actually 1.21. 1.21. That is D bar. And SD equals to 12.68. So the confidence interval will become 1.21 minus 1.771, and then SD is 12.68 over square root of 14. So because we have a total of 14 differences, and less than mu D less than 1.21 plus 1.771, and we got 12.68 over square root of 14. So this part will be 7.21 greater than mu D, and then greater than minus 4.79. Note that this confidence interval, does it include 0? Does include 0. Okay. So this implies that at a 90% level of confidence, the data do not support the claim that the two cars has different mean parking times, mu1 and mu2. So the difference between the means, okay? So the difference in the time taken to parallel park two cars, they are not significantly different in the 90% level of confidence.